Om Shri Sai Ram. Dear students, welcome to the third chapter of 9th standard mathematics. This chapter is divided into two videos. This video has a small introduction to the chapter, a brief recap of the previous chapter, few definitions of basic terms, and then types of lines and pairs of angles. Look at this picture. Suppose you are asked to redraw these pictures exactly as it is. So what are the geometrical instruments you need to redraw these pictures exactly? So you need a scale, ruler, to measure the lengths of the line segments and to draw the line segments. Is it enough? With the scale we can draw the lines and we can measure the length of the line segments. So to measure the inclination of the line, how much is it inclined, this line. So we need protractor. So with the help of protractor, we can measure the angles and draw the angles. So protractor is used to measure and construct the angles. So this chapter deals with lines and angles. You know that the most of the geometric chapters which we are studying in present days are all based on Euclidean geometry to prove most of the problems, theorems. We use the postulates, the axioms, and few theorems given by Euclid. So let us recall few axioms and postulates which you had studied in the last chapter. The important axioms are: first one, things which are equal to the same things are equal to one another. If equals are added to the equals, then the wholes are equal. If equals are taken away from the equals, subtracted from the equals, then the remainders are equal. Next, things which coincide with one another are equal to one another. The whole is greater than its parts. Things which are halves of the same thing are equal to one another. Halves of equals are equal. So among these first three axioms, we use more often. Let us look at some postulates. So postulate number one, a straight line can be drawn from any one point to another point. A terminated line can be produced indefinitely. A circle can be drawn with any given center, with any given radius. So all right angle triangles are equal to one another. And the fifth postulate is, if a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than two right angles. So Euclidean fifth postulates. It made some sound. So not only in your previous chapter, but also when Euclid stated this statement, so many mathematicians scratched their head, and it led to the equivalent postulates. Many mathematicians given equivalent postulates for this. You had learned it in the previous chapter. So once again I will explain the meaning of this postulate. So if a straight line falling on two straight lines, so consider two straight lines. So let L1 and L2 be the two straight lines. A line is falling on it. Let line T, actually it is a transversal, line T fell on it. Then it says, if the interior angles on the same side of this line, so these four are the interior angles, this and this, these two a pair of interior angles on the same side of the transversal, and this are the another pair of interior angles on the same side of the transversal. If sum of these two angles is less than 180 degree, less than two right angles, then these lines will meet when we produce them infinitely. So they will meet in some other points. If these interior angles togetherly more than two right angles, then they will meet other sides. Here you can see some of these two interior angles is more than 180 degree, therefore they will meet other side. When you produce this side, they will meet. So that is the meaning of this postulate. So equivalent to this postulate, one of the equivalent famous postulate was Playfair postulate, equivalent version. So it states, for every line L and for every point P not lying on L, there exists a unique line passing through P and parallel to L. If there is a line L and there is a point outside that line, suppose here is a point P. So among all the lines which can be drawn through P, a unique line, only one of the line is parallel to L. So among these infinite lines, only this line M is parallel to L. Similarly, we have a unique line which is perpendicular to L also. If I draw a perpendicular here, so among all these infinite number of lines, only one of the line is parallel to L and only one of the line is perpendicular to L. So that is the meaning of this Playfair postulate. Let us see some definitions. Look at some definitions. What is it? Is it a point? Point A, is it not? If you agree that it is a point, so what about these? Are these also points? Confusion started. No? So these are very big, this is very small. Sometimes we call a point is a small dot. If you think so, a point is a small dot, how much small it should be? Are you agree this is a point, or I will write some point here. Here is some point which I am not seeing. Can you agree this is a point, or can you agree is this the point? So we can't say. So actually we represent the point by putting a small dot. The dot itself is not a point. We have to imagine it is an abstract concept. Similarly for lines and planes also. This picture is not the line. To represent a straight line, we use such type of pictures. So even though Euclid defined point, line, plane and so many things, so these three terms, the mathematician declared that point, lines and planes are undefined terms. But we have definitions in Euclidean geometry. Euclid defined it. For the point, Euclid defined as a point is that which has no part. Here a question arises, what is the meaning of part? So therefore this definition is rejected. But for our understanding, for our convenience, so we define point as a point is an exact position on a plane surface. So it is important to understand that the point is not a thing. It is not a thing. It is not a dot, but a place. It is a position without dimension, without length, without breadth, height, like that. So we indicate the position of the point by placing a dot with a pencil. So in the previous classes, you know that meaning of collinear and non-collinear points. If three or more points are on the same lines, then we call them collinear points. Here, point A, point B and point C are collinear points because we can pass through a line passing through them. Point P, point Q, point R. It is not possible to pass a straight line through them. Therefore, they are called non-collinear points. Let us go to the lines. So Euclid defined a line as it is a breadthless length. Here the question arisen was, what is the meaning of breadth? What is the meaning of length? So therefore this definition was rejected. For our convenience, we define a straight line as it is a set of points between and extending beyond 2 points. So it has a single dimension, only it has only length, it is extended in two directions forever. If P and Q are 2 points, all the points between them and behind them also, so it can be extended forever. So is a straight line. If two lines maybe intersect, here line M and L1 are intersected here, and L2 and M also intersected here. So we can name a line using English small letters like L, M, N, T or L1, L2, or we can use the 2 points on the line to name the line. So sometimes we call the horizontal lines the line parallel to the table or parallel to the ground, horizontal line. So this is called vertical line, this is called oblique lines. So when we study two or more lines together, so we have parallel lines, intersecting lines. So let us study details in later. Now go to the line segment. So it is the part of the line with the two endpoints. If we cut a straight line into two places, so we get a line segment. So it is named like this, line segment AB. So ray, so it is also a part of a straight line which has a starting point. You can call it as an end point also, one end point, and one side it is extended forever. So it is a ray, and this is the notation to represent a ray. Now let us move to the angles. An angle is a figure formed at the common origin of two rays. So here is the common origin, it is called vertex of the angle, and OA and OB are the two rays started from common vertex. The picture formed here, this sharpness is nothing but an angle. The measure in degree between two rays having a common origin is called an angle. It is another definition. So angle is the measure between two rays having a common vertex in terms of degrees. So if we measure the distance between rays in terms of degrees, then the distance here in degrees, the distance here in degrees, the distance here in degrees, all will be same. But if we measure in centimeters, then this distance differs. So one more definition which suits the angle is the measure of rotation of a ray on its origin. Ray OA is rotated to the position B with point O in the same place. You can see once again. Yes. We can name this angle as angle AOB, angle AOB. We can name it as angle BOA, or simply sometimes we name it as angle O because O is the vertex. Sometimes we use this notation also to write the angles. Here O is the vertex, OA and OB are called arms of the angle, or we can call them sides of the angles. Now go to the types of angles. So you all know this. The angles are classified on their measurements. So look at the protractor. If I take a base here, one line, and another line here, then we have two angles. One angle is here. So here to here it is 90 degree. Similarly here to here also it is 90 degree. The angles which measures less than 90 degree, suppose I'll draw a line here, then this angle measures less than 90 degree. This angle is 45 degree here. If you measure from this side, it becomes 135 degree. So it is more than 90 degree. The angles which measures less than 90 degree are called acute angles. You know it. So it is an acute angle. The angles which measures exactly 90 degree are called right angles. Obtuse angles are more than 90 degree and less than 180. Straight angles measures exactly 180 degree. And reflex angle, the angles which measures more than 180 and less than 360 degree, the complete angle is 360 degree. So if we measure this angle from here to here, it becomes a reflex angle. If we measure this angle from here to here, between these two rays here, so we get an acute angle in this picture. Now go to the pairs of angles. So pairs of angles means, so two angles connected in some or other ways. So first we have supplementary angles and complementary angles. So if the sum of two angles is 180 degree, sum of the measures of the two angles is 180 degree, then they are called supplementary angles. If the sum of two angles is 90 degree, then they are called complementary angles. Here one of the angle is 60 degree and another angle 120 degree. Togetherly they are called supplementary angles. The angles may be like this, side by side, or the angles may be separate. Anyhow, if the sum of two angles is 180 degree, then they are called supplementary angles. Similarly, complementary angle. For complementary angles, the two angles, they may be separate angles. They may be angles like this, side by side. If their sum is 90 degree, they are called complementary angles. Adjacent angles. So two angles having a common vertex and a common arm. Not only that, their non-common arms are on different side of the common arm. They are called side by side angles, adjacent angles. So in these figures, angle ADB and angle BDC, a pair of adjacent angles. Look at this picture, angle ADC and angle ADB, they are not adjacent angles, because if I take angle ADC and angle ADB, so both have D as common vertex, the common side here also AD, so ADB and ADC, so in these two, DA is the ray which is common for both the angles. The ray DA is called common arm. And the non-common arms DB and DC, they are on the same side of the common arm. Therefore, these two angles are not adjacent angles. So if I take angle ADB and angle BDC, then the common arm is DB, non-common arms are DA and DC, they are on either side of the common arm. They have a common vertex. So therefore this angle and this angle are called a pair of adjacent angles. Here angle AOD and angle DOB are adjacent angles. So there also angle 1 and angle 2 are adjacent angles. If AOB and BOC are two adjacent angles, AOB and BOC, they are adjacent angles, then their sum, angle AOB plus angle BOC, should be equal to angle AOC. So in this picture, here angle ADB and angle DBC are adjacent angles, their sum is equal to angle ADC. So they are adjacent angles. Linear pair of angles. If two adjacent angles are such that their non-common arms form a straight line, then they are called linear pair angles. In other words, if the sum of two adjacent angles is 180 degree, then they are called linear pair angles. So it leads to the two postulates. They are called, or axioms, they are called linear pair axioms. So which states, if a ray stands on a line, then the sum of two adjacent angles so formed is 180 degree. In this picture, ray OB, so it is standing on a straight line AC. So when a ray stands on a straight line, then we have two adjacent angles, angle 1 and angle 2. So no doubt their sum is 180 degree. So these are called linear pair angles. Its converse, if the sum of two adjacent angles is 180 degree, then the non-common arms of the angles form a straight line. So these two axioms togetherly called linear pair axioms. Now go to the vertically opposite angles. So when two straight lines intersect at a point, then the opposite angles at the common vertex, here angle AOD and angle BOC, a pair of vertically opposite angles. Angle AOC and angle DOB, it is another pair of vertically opposite angles. Now we have a theorem on this. So whenever two straight lines intersect at a point, then the vertically opposite angles are always equal. So you know what is theorem? So with the help of axioms and few known definitions, using known definitions, if we prove some statements, those statements are called theorems. So let us prove this theorem. So the statement of every theorem consists two parts. One part is called hypothesis part. Reading the statement, something we have to assume, that part is called hypothesis part, and another part is called conclusion part. Something we have to prove. So that is called conclusion part. Here, if two lines intersect each other, so that is the assumption part. This is the assumption part. For this, we have to draw a diagram. Two lines intersecting at a point. So I will draw line AB and CD. So they are intersecting at a point, call it as O, point O. Data contains the explanation of the figure. So in that figure, AB, the line AB and the line CD, they intersected at point O. Now go to the conclusion part. Then the vertically opposite angles are equal. We have to prove that this angle is equal to this angle and this angle is equal to this angle. That means to prove, what we have to prove is, so angle AOD is equal to angle BOC and angle AOC, so is equal to angle BOD. We have to prove that the vertically opposite angles are equal. So to prove this, we use the other axioms. Proof. So look at the picture. So we know that sum of these two angles is equal to 180 degree. They are linear pair angles. Angle AOD and AOC. They are linear pair angles. So write it. So in the figure, angle AOC plus angle AOD, so is equal to 180 degree because they are linear pair angles. Now take the sum of these two angles, angle AOC and angle BOC. They are also linear pair angles. In the figure, angle AOC plus angle BOC, it is also 180 degree. They are also linear pair angles. Now compare these two equations. So both the equations have 180 degree in the right side. So recall the first axiom, things which are equal to same thing are equal. Sum of these two is also equal to 180 degree. Sum of these two is also equal to 180 degree. So we can write the sum of AOC and AOD is equal to, so the sum of AOC and BOC. Things which are equal to same thing are equal. So it is axiom number 1. So look at this equation. In both the sides we have AOC. We can remove it. That is axiom number 3. If equals are taken from the equals, then the remainders are equal. Third axiom. So if I remove AOC from both the sides, we get AOD is equal to BOC. AOD is here, BOC is here. They are equal. That's what we needed to prove. In the same manner, we can also prove that angle AOC is equal to angle DOB. So let us look at all these steps again. To prove any theorem, first we have to draw a diagram by understanding the hypothesis part of the theorem. That is the diagram. Then we have to write the data, so which contains the explanation of the diagram. So in that diagram, AB and CD, they are intersected at O. Now the conclusion part, what we have to prove, that we have to write here. To prove, we have to prove that angle AOC is equal to angle BOD. Vertically opposite angle AOC is equal to angle BOD, one pair of vertically opposite angles, and angle AOD is equal to angle BOC, another pair of vertically opposite angles. Take one pair of linear pair angles I am taking angle AOC and angle AOD. Angle AOC plus angle AOD is equal to 180 degree. Take another pair of linear pair angles such that one of these angles must include here. So I am taking angle AOD plus angle DOB. So here also it is AOD, here also it is AOD. AOD plus DOB is equal to 180 degree because they are also linear pair angles. So on comparing these two equations, we have 180 degree in the right side of both the equations. So apply the axiom number 1, things which are equal to same thing are equal. So we have sum of these two is equal to sum of these two. On both the sides we have AOD, a common factor. We can remove it according to axiom number 3. If equals are taken from the equals, then the remainders are equal. So that we needed to prove angle AOC is equal to angle BOD. Here it is proved. So similarly we can prove another set of vertically opposite angles. Now let us go to solve some problems related to these pairs of angles, mainly linear pair angles and the vertically opposite angles. So carefully read the problem. So in the figure, line AB and CD intersect at O. Angle AOC plus angle BOE togetherly it is 70 degree. Angle AOC is here, angle BOE is here. Sum of those two angles is 70 degree. Angle BOD is 40 degree. So angle BOD, this angle, it is 40 degree. Then we have to find out angle BOE. So BOE, we know that angle BOE plus AOC is 70 degree. We have to find out the individual BOE angle and the reflex COE. Angle COE is this, less than 180 degree. So reflex COE means from here to here, that is 360 minus this common angle COE. So in this picture, angle AOC plus angle BOE is equal to 70 degree. It is given AOC plus BOE is equal to 70 degree. It is given that AB and CD intersected at O. These two are straight lines, therefore the vertically opposite angles are equal. And BOD is given as 40 degree. BOD is 40 degree. Therefore AOC is also 40 degree. See, AOC plus BOE is 70 degree. So we came to know that angle AOC is equal to 40 degree. So therefore BOE is 70 minus 40. So that is equal to 30 degree. To find out reflex COE angle, there are two methods. One method you can find first, you can find out this angle COE, then subtract it from 360 degree. To find out angle COE, there are two methods. So I will use the method. So sum of these three angles is 180 degree. So angle AOC plus angle COE plus angle BOE is equal to 180 degree. So in these three angles, we know the sum of these two angles given here. So instead of these two angles, you can write 70. So 70 plus COE is equal to 180 degree, a straight angle. So send this 70 to that side, you get angle COE is equal to 110 degree. So this angle is 110 degree. So it is asked to find out the reflex COE, that is this angle. So subtract 110 from 360, so you get 250 degree. The reflex COE is 250 degree. Let us look at one more problem. So in the figure, XY and MN intersect at O. If angle POY is equal to 90 degree and A is to B is equal to 2 is to 3, find C. C is here, A and B are here. POY is 90 degree means POX is also 90 degree. That is A plus B is equal to 90 degree and A is to B is given as 2 is to 3. So you know how to find out A and how to find out B. Angle XOP is equal to 90 degree. So A is equal to, so 2 plus 3, 5. So 2 parts out of 5 parts. So 2 by 5 times of 90 degree. The sum of A plus B is 90. Therefore A is 2 by 5 times of 90, that is 36 degree. If you subtract that 36 from 90, you get the value of B. So B is equal to 90 minus 36, that is 54 degree. So B and C are linear pair angles. MN is a straight line, OX is a ray standing on that straight line. Therefore, these two are linear pair angles. Their sum is 180 degree. B plus C must be equal to 180 degree. We know the value of B. B is 54 degree. Therefore, C is equal to 180 minus 54. That is 126 degree. Next problem. In the figure, x plus y is equal to y plus z. Then prove that AOB is a line, straight line. If we prove that x plus y is equal to 180 degree, then we can call AOB is a straight line. We have to prove that x plus y is equal to 180 degree. It is given that x plus y is equal to y plus z. So add all the four angles, we get x plus y plus z plus w. So we get 360 degree. So in the place of w plus z, that is z plus w, we can write x plus y again. So therefore, we get 2 times of x plus y is equal to 360 degree. So look at the steps. X plus y is equal to w plus z, it is given. If we add all the four angles, we get a complete angle 360 degree. But we can write x plus y in the place of w plus z because it is given here. If I write x plus y here, x plus y plus x plus y is 2 times of x plus y. Send this 2 to that side, coefficient always goes to denominator. Therefore 360 by 2, it becomes 180 degree. X plus y is, in this picture we proved that x plus y is equal to 180 degree. So therefore AOB must be a straight line. So according to linear pair axiom, second axiom. The last question. In the figure, POQ is a line. POQ is a line. Ray OR is perpendicular to line PQ. OS is another ray lying between rays OP and OR. Prove that angle ROS is equal to half of angle QOS minus POS. So look at here. Angle ROS, angle plus angle POS. So don't consider this 2 now. Look at angle ROS plus POS. ROS is here, POS is here. So it is given that OR is perpendicular to PQ, OR is perpendicular to PQ. Therefore, sum of these two angles is equal to 90 degree. If I multiply all the terms with 2 or both sides with 2, so we get 2 times of ROS plus 2 times of POS is equal to 2 times of 90, that is 180 degree. Now consider angle QOS plus angle SOP, that is POS. They are linear pair angles. Their sum is also 180 degree because they are linear pair angles. Angle QOS plus POS is equal to 180 degree. Now subtract second equation from first equation. So we get here 2 ROS as it is, 2 POS minus POS. We get, that is POS, and QOS we are subtracting, therefore it is minus QOS. So 2 ROS as it is, we are subtracting, therefore it becomes minus angle QOS, and here we are subtracting these 2 times of angle POS minus 1 time of angle POS, it gives angle POS is equal to 180 minus 180, that is 0. Now send these 2 terms to right side, we get 2 times of angle ROS is equal to minus QOS becomes plus angle QOS, and plus angle POS becomes minus angle POS. So take this 2 to that side, coefficient always goes to denominator, it becomes half there. So therefore ROS is equal to half of angle QOS minus angle POS, that we needed to prove here. Students, these 2 questions are for the assignment for this video. So let us stop here. Jai Sai Ram. Thank you.